Welcome back to our channel. In this video we will build an app in Flask, Python and JavaScript to transcribe your voice live in the web browser. If you are curious how to do that, let's get started. The first thing we will do is install the new environment and activate it. After that, we will install the latest version of Python Package Manager pip. Then we will proceed with the installation of the project requirements. The requirements include Flask, Flask Cores and Whisper. We will install all the necessary requirements as specified. Next, we will create the main file, the templates directory and the index.html file within the templates folder. Additionally, we'll create a static directory to store all the static files. Moving on, we will start working on the code in the main.py file. We will import all the necessary dependencies and create the Flask app. We will define the main route or path where we will render templates. If the file is run as main, we will activate the debug mode and run it on port 8000. The next step involves creating the code for the index.html file, including all the required tags and content. During testing, you may encounter an orange warning indicating the presence of an .env file or a .flask.env file, which suggests installing python.env. Although we are not using python.env for this project, we will install the python.env file. Upon restarting the server, the warning should disappear. With a now properly set up environment, you will see the message it works. Now let's address an error you might encounter. If you check the browser's console menu, you may notice an error related to the favicon icon. To resolve this, you can copy and paste the favicon icon into the stack folder and reference it in the index.html file. Upon the rerunning server, the error should be resolved and everything will work fine. Moving on, we have the /API/transcribe route, which uses the post method. Initially, we will start with the return message, displaying a success message upon completion. To transcribe the audio, we will import the audio file using the request. We'll save the audio as audio.wav and pass it to the function called transcribe audio, which will return the transcribe text. The transcribe audio function will be initialized to handle the audio file and return an empty string. To handle bad requests in this route, we'll implement error handling. If for some reason the audio file is not found in the request, we will return a JSON response with success set to false and an invalid HTML error code of 400. Let's focus on the transcribe audio function. We will move to the model creation outside of the function so that it is loaded only once and stored in the computer's memory to eliminate the need for extra loading each time the function is run. We will specify that it should use a floating point precision of 32 bits instead of 16 bits. We will also set conditional previous text to false as we don't want the model to remember previous input. Finally, we will set initial prompt as an empty string and specify the language as English. Additionally, we can add a language parameter to the function argument for future use. So the server side is done. The next thing we have to do is focus on the JavaScript part. Let's create a start button, a stop button, a text area and the respective IDs. We will also set up on-click references to functions like start and stop. And of course, we need to initialize these functions. Next, we want to reference these buttons using the document.getElementById method. We will assign the buttons to variables so that we can perform operations on them. For example, when we click on the Start button, we will disable it and enable the Stop button and vice versa. If everything works fine, we can click Start and Stop, and it will disable and enable the other button accordingly. However, the main functionality is not yet implemented. Let's create two functions, Start Recording and End Recording. In the Start Recording function, we will use the navigator to access our media devices, specifically the audio. We will create the recorder and initialize it with a stream. The recorder should be declared outside the function so that it can be accessed by other functions as well. The recorder should start, and when data is available, it should send the audio. In the End Recording function, we will stop the recorder by calling the recorder stop. In the Send Audio function, we will push the data to an array called chunks and create a blob with the chunks as audio in the format audio/wave. Afterwards, the chunks should be reset to an empty list. Let's create a variable called form_data to hold a new form_data object. We will append the audio blob to the form_data object and name it audio.wave. We will use the fetch function to make an HTTP request to the server. The server is located at localhost port 8000. The body of the request will contain the form_data. If we receive a response, we will pass it as JSON and output the success message. If the success is true, we will display the success message in the text area box. As a precaution, we should also implement a catch method to handle any errors and print them to the console using console.error. So now the Start and Stop buttons will control the recording. However, we want the recording to be sent in intervals to the server so that it is transcribed periodically. We will set the Start Recording function to the Start button and the End Recording function to the Stop button. We will also define an interval of 2 seconds. Within this interval, after starting the recording, we should end the recording and start it again. Each time the recording ends, the data should be sent to the server. In the Stop function, we just need to clear the interval. Also, I made a mistake earlier. We should initialize the chunks variable as an empty list. Let's see what is happening right now. It is working, but there's a slight mistake. If there are any audio difficulties, or if the transcript audio function doesn't work well, we can use a try and accept block in the server-side code. If there is an error, we can output an empty string. Let's see what happens if I talk like this. It actually works. To make it stop properly, we have to initialize the interval outside of the functions, so that we can call it within the functions. We have successfully implemented the new project where we can perform live translations. Finally, let's try our app. I'm trying it once more after I fixed the bug, so maybe it is working now. As you can see, it is not quite right. If you want more accuracy, just use a bigger model. Don't use the base model, use the medium or large one, but it will result in more time-consuming responses. Now I will show you how you get even better results. Change the interval to 1 second. Do not reset the list chunks. And instead of adding text, set the whole new text as the new value for that text area. So if we talk now like this, it is even better than before, because it is now adding all the audio together. It will get the whole audio, and all the words are after another, which makes more context. Therefore, it is better. If you liked the video so far and you watched till the end, please hit the like button and subscribe to my channel.